Hey, this is Horner, and we're going to take a look at Electrostatics Notes Part 4, which you absolutely need to know to pass the electrical circuits part of the AP Physics 1 exam. This section starts with parallel circuits. So this is our other type of circuit that's a basic circuit type. It's called a parallel circuit, and there's more than one current pass. So notice that we can go from here all the way back to the battery. We could also go all the way through the second resistor, and we could also do the same thing with the third one. So in this one, you can have three different paths. And to find the resistance in a parallel circuit, we cannot just add the resistances. What we have to do is we have to do 1 over the equivalent resistance is equal to 1 over the first plus 1 over the second plus 1 over the third. If you use this equation, when you use this equation, you have to be really careful that when you get a number in the end, so let's say that I have 1 over R EQ is equal to 20, I need to make sure that I flip both sides. So really, REQ would be equal to 1 over 20. So you have to be very, very careful when you do this. If you want to have, if you only have two resistors, you can use a shortcut. And this is the shortcut. And it's not on your equation sheet. So only use it when you have two, and only use it if you want to memorize it. Makes it a little bit easier for two resistors. We have three resistors in ours, and so we need to use the same equation that you see up here, and we're going to do 1 over 2000 plus 1 over 2000 plus 1 over 2000, and that would be 3 all over 2000, which if you take 3 divided by 2000, you get 0.0015. Be careful because that is not your answer. That is 1 over R. If I do the reciprocal both sides, so I multiply this, I flip this one and get R over 1. This one I would do 1 over 0.0015. I will end up with R is equal to 667 ohms. Now we can again use the VERP table, but we have to be careful when we fill out the VERP table. We need to fill out what we know from the circuit diagram. And one of the things that we already knew was the 12 volts. So if you look, the battery that they have on this circuit is 12 volts. And we also have three resistors, all of which are the same. But be careful with this one because remember we cannot just strictly add all three of the 2000s and make 6,000 ohms. That was in a series circuit. So in a circuit that is a parallel circuit, there are some things that are a little bit different. One of those things that are different is that whatever the voltage is in the entire circuit, so we know that the battery is 12, each one of the resistors in a parallel circuit gets the same amount of voltage. Because they all get the same amount of voltage, we now need to go through and figure out what is the current in each one. So the current from our equation I is equal to V over R would be 12 divided by 2000, and you end up with 0.006 amps. And so you'll see in this table we've got that 0.006 amps. They're all the same because our resistance is the same. If the resistances aren't the same, obviously these are not going to be the same. Using Kirchhoff's current law, we know that the 0.006 amps flows through each of the resistors. So if it flows through each one of the resistors going in, so we've got in the first resistor, the second, and in the third resistor, we have 0.006, 0.006, and 0.006. We have to have the same coming in as we do going out. There's no way we can have 0.006 going in because that doesn't add up to 0.006, 006, 0.006. So we've got to add the three together. If you add these three together, you'll get 0.018 amps going in and 0.018 amps coming out. So when you do the current for this one, we actually add the currents. Like we added the resistance in series, in parallel we add the currents. So we've added those currents together. Now that we know the voltage and we know the current, we can now find out what is the total resistance. There's two ways to do it. We could either do it the way we did earlier, or because now we have voltage and we have current, we can say R is equal to V over I. Our V is 12, our I is 0.018, And when you divide those two, you do get the same answer we got before, which is 667 ohms. Finally, we can find power the same way we found it before, where we just say power is equal to I times V. If I multiply V times I get 0.072. Be careful because the last power is not the same. It is the sum of all these, or you can multiply the V times the I for the whole thing and you get 0.216. For resistors in parallel, the equivalent resistance uses the inverse of the sums. The voltage here is the same and the current adds, and that's much different than what we had for series. In series, we said that the current is the same. We said that the voltage adds, oops, it's going a little slow, the voltage adds, and the resistance is 1 over the resistance is equal to 1 over the first plus 1 over the second resistance plus dot, 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 on and on and on. So the rules are just opposite. Current adds in parallel, in series it's the same. Voltage is the same in parallel and it adds in series. And then this resistance, oops, is the inverse sums. So remember, sorry, that's for parallel. In series, it just simply adds. So I made a little bit of an error there. Hopefully you can see that. And so that is how you do things in parallel. Let's go ahead and take a look at the first problem, which is question number 33. It says a 15 ohm resistor R1 and a 30 ohm resistor R2 are connected in parallel between points A and B. They want us to complete the diagram. So to complete the diagram, the easiest way to do this is to make a double line like this, and then put one resistor on top, and then put another resistor on the bottom. And so here we know that one of these is R1 and the other one is R2. It says determine the potential difference across resistor R1. So here's R1, here's R2. 15 ohm resistor, this one's 15, this one is 30. And remember that the voltage is the same in each one. So the potential difference here is going to be the same as what's in the battery. And so we know that this is 90 volts. So here we have 90 volts and here we have 90 volts. Now they want us to calculate the resistor R1. We want to find the current. So to find the current for this one, we can go through and basically just use V is equal to IR. So I is equal to V over R for this one. Our voltage is 90. Our resistance is 15. And so if we take 90 divided by 15, we find out that the current is 6 amps. We didn't use our VERP table for this. We could have, but this one is just asking for the current just in this resistor. So we already knew what the voltage was, we already knew what the resistance was, so we went ahead and just did our math. And we ended up with 6 amps of current in this one resistor. For question number 34, it says draw a diagram of an operating circuit that includes a battery source, 2 resistors in parallel, and an ammeter that reads the total current. So this one's a little bit tricky because here we've got a battery. Remember, a battery is more than just one long and one short line. It's got to have both. And then we're going to go up. We're going to come over to a resistor, go back, come back down. We're going to leave a little space there and move back over. And we're going to do the same thing up here. And now we've got our 2 resistors. We have our battery, but they also want an ammeter to find the current in the whole circuit. So we're going to put that ammeter right here. Remember, it's got to be in line. And that is the answer to number 34. Number 35 says we have 3 identical lamps. They are all connected in parallel with each other. If the resistance of each amp is X, what is the total resistance? So here we know that 1 over R is going to be equal to 1 over the first plus 1 over the second plus 1 over the third, which is really equal to 1 over X plus 1 over X plus 1 over X, which is equal to 3 over X. And now I've got to flip both this and I have to flip this. So I'm going to have R over 1, I have to write the 1, is equal to X over 3. And so when we look, the only one that fits that is letter B. So it is X over 3. For question number 36, it says there are 3 resistors, one of 4 ohms, one of 6 ohms, and one of 8 ohms. They're connected in parallel in an electric circuit. The equivalent resistance of the circuit is, so here we're going to do 1 over the total is equal to 1 over 4 plus 1 over 6 plus 1 over 8. And we will always, when we add these up, you're going to find out that the total resistance should always be less than the smallest resistor. So our smallest resistor here is 4. And so our answer is simply just A. But to prove that, let's do a common denominator. Common denominator would be 24. So this would be 6 over 24 plus, here we've got 4 over 24 plus 3 over 24. 6 and 4 is 10, plus 3 would be 13 over 24. And that, remember, is 1 over R. So to get R, we're going to have to take 24 divided by 13. And when you actually physically do 24 divided by 13, you should end up with 1.85 ohms. And so obviously that's a lot less than the smallest resistor, which is 4 ohms. So the shortcut way is just to look, whichever one is the smallest, which is this one, we can ignore the other two. The total's got to be less than 4. Number 37 says we have a 3 ohm resistor, an unknown resistor, and 2 ammeters, A1 and A2, and they're connected as shown. Ammeter A2 reads a current of 5 amps, and so they've put that in. The thing that they want us to do for this one first is to find the resistance of the circuit, calculate the current, and then calculate the resistance of the unknown resistor. So it looks like we're going to need to use our VIRP table. So V, I, R, P. We'll go ahead and put in R1, R2, and our total. Our voltage here for each one, remember in parallel the voltage is the same. So it's 12, 12, and 12. Our current, we know not really much anything about yet, so we're going to wait on it. We do know that the total current, since the current going into this branch has to be the same coming out, the total current here is 5 amps. So 12 volts, we have 5 amps. The resistance in the number 1, so here's number 1, is what we'll call it, is 3 ohms. We're not sure what the total resistance is. So let's do a little bit of math to find out the total resistance. I know that the total resistance, so remember V is equal to I times R. So R is equal to V over I. Our voltage is 12, our current is 5, and so if you divide the two, we're going to end up with a total of 2.4 ohms. So that's our total resistance. To find out what our unknown resistance is, we're going to have to do a little bit of math. We know that 1 over 2.4 should be equal to 1 over 3 plus 1 over the resistor that we don't know. So let's just make this really simple. We're going to take 1 divided by 2.4. That's equal to 0.4167. We're going to do 4 decimal places for each one of these. 1 divided by 3 is 0.3333, and we add that to 1 over R. So we need to subtract 0.3333 from both sides, so that'd be 0.4167 minus 0.3333 gives us 0.0834, and that's equal to 1 over R. Now we just flip both sides, so 1 divided by 0.0834 is equal to 12, or 11.99999. So this is really 12. So this one is 12 ohms. Notice they don't add up. They shouldn't. It's because we'd have to do 1 over the first plus 1 over the second should be 1 over the total. Now that we know those, we can go back and we can find the current in each one of these. So to find the current, remember V is equal to IR, so I is equal to V over R. So 12 divided by 3 would give us 4 amps, and 12 divided by 12 would give us 1 amp. So these are each 1 amp. Remember the voltage is the same. the current adds, and the resistance is 1 over 3 plus 1 over 12, and that would be equal to 1 over 2.4. Now that we've done that, we should be able to go ahead and put all our answers in. So the equivalent resistance of the circuit is 2.4 ohms. The current is 4 amps in that resistor number 1, okay? And then the unknown resistor is 12 ohms. So our unknown resistor would be 12 ohms. And at that point, we are done with number 37. Number 38 is another parallel circuit, and it says, what is the current measured by ammeter A? They want to know what's the equivalent resistance and how much power is dissipated by this 36 ohm resistor. Once again, we're going to need to use a VERP table, so we're going to say V, I, R, P. We're going to have resistor 1, resistor 2, resistor 3, and resistor 4. So we have several resistors here. The voltage for each one we know should be 12, and our total voltage then is also 12. Resistor 1, we're going to say that this one is number 1, 2, 3, and 4. 1 is 6, 2 is 12, next one is 36, and then 18. From this, we can go ahead and find out what is our current for each one. So the current for the first one would be 12 divided by 6, and that should be 2. The next one is 12 divided by 12, and that one is simply just 1. 12 divided by 36 would give us 0.33, and 12 divided by 18 should give us 0.67. We also remember that the current going in needs to be the current going out, so it should be the sum of all these added up. 0.67 plus 0.33 gives me 1. Plus 1 is 2, plus 2 would be 4, so this is 4. Now we can easily find the resistance by just using our resistance is equal to, well, remember V is equal to IR, and so our resistance is equal to V over I. So our voltage is 12 divided by 4, that gives us 3 ohms. Now we don't have to go through 1 over and do all that work. If I want to know what power is, remember it's just V times I, so power is equal to VI or IV. So 12 times 2 is 24, 12 times 1 is 12, 12 times 0.33 is going to give us 4, and 12 times 0.67 gives us 8. And for this one, we should be able to just go through and add them up, and we get a total power of 48 watts. So when it says how much current is measured in ammeter A, we know that that would have to be 2 amps because that was the current in the 6 ohm resistor. What's the equivalent resistance? We said it's 3 ohms because we found it here. And then how much power is dissipated in the 36 ohm resistor? We go to the 36 ohm and we notice that that is 4 watts. And so that's where the VERP table really comes in handy. That's a really nice way of going through and doing these. We have another problem. This is number 39. Number 39 says you have a 20 ohm resistor and a 30 ohm resistor connected in parallel. What is the equivalent resistance of the circuit? Now, if you remember, the nice thing about this one is we can do a VERP table again. So we're going to do V, I, R, P. We have two resistors, resistor 1 and resistor 2. So we'll call this one 1, call this one 2. The voltage here is 12, 12, and 12. The resistance is 20. We also have 30. We need to find out what is the current. So I'm going to take 12 divided by 30 because remember I is equal to V over R. And so here we've got 0.6. Here we've got 0.4 because 12 divided by 30 is 0.4. If you add those, you get 1 amp. So this is 12 volts, 1 amp. We can't just add these and make 50. We probably make it a little bit easier. We're just going to use, we know the resistance is equal to V over I for the total. And so 12 divided by 1 is going to give us 12 ohms. That way we don't have to do 1 over or even the shortcut method. 12 times 0.6 is going to give us 7.2 watts. 12 times 0.4 is going to give us 4.8 watts. 8 plus 2 is 10. 7 plus 4 is 11. Plus 1 is 12. And so our total power here is 12 watts. When we answer the questions, the equivalent resistance we see is 12 ohms. The current reading of the ammeter should be, for this first one, it's the 20, so the current reading is 0.6. And finally, the power of this resistor we see is resistor 2, and it's 4.8 watts. So now we've got all of our answers for number 39. Let's check and see. We've got one more here. It says in the circuit diagram below, the ammeter A1 reads 10 amps. What is the reading of ammeter A2? So this is another one that we can just use our good friend the VIRP table. So we're going to do VIRP. We know the voltage for the first resistor is something that we don't know. Okay. In fact, this one, I think the thing that they forgot to give us here was nothing. They didn't give us voltage, but we can find it. So I know that the resistance in the first one is 20 ohms, and the second one is 30 ohms. And the total current that runs through this whole circuit, so that's R1 and R2, this is total, the total current that runs through the circuit is 10 amps. We need to find out what is the sum of the two. So we're going to do 1 over the total is equal to 1 over 20 plus 1 over 30. We can probably do a common denominator. We just make it 60. So this would be 3 over 20 plus 2, oops, sorry, we said 60, didn't we? So 3 over 60 plus 2 over 60, that would give us 5 over 60. And so if you take 60 and divide that by 5, we end up with 12. And so our total resistance here is 12 ohms. At this point now, we can say V is equal to IR. So I is 10, R is 12, so this would be 120 volts, which means each one of these is 120 volts. Now we can go ahead and find out what the current is in 2 and 3. If this is 10 amps, we know that these two should add up to be that. So 120 divided by 20 is 6. 120 divided by 30 is 4. So I know that this one is got to be 6. This one has got to be 4. And the meter reading for A2 then is 6 amps, and our answer is A. And that is the end of parallel circuits.